Okay, so this is the two vector equations of the lines that we've got. Okay. Now, first thing which we need to check before we do anything else, are they parallel, are they intersecting, or are they skew? So, what's the first thing we need to check? Parallel. So let's check to see if there's a constant, there's a scalar which matches all these three things up. So we'll have a look at direction vectors. So we've got 1, 3, -2 for this one, and we've got 4, -3, and -4 for this one. What we're basically saying is that there should be some constant, if they're parallel, there should be some constant which when we multiply it by each of these things is the same, okay? Or another way of saying that, if we divide that by that, we should get the same thing, okay? So that would be 4. -3 divided by -3 is -1, and -4 divided by -2 is 2, okay? So therefore, because there's not just one constant, which is, so it's not a scalar multiple of this, then it cannot be parallel, okay? So, not parallel. Okay, so what's the next thing that we need to check? Intersecting. How do we check whether they're intersecting or not? Yeah, exactly. We need to set them equal to each other. So we've got 8 to -4 plus lambda plus 3 lambda minus 2 lambda, and on the right hand side we should have -2 plus 4 mu, and then we have 2 minus 3 mu, and then we have 8 minus 4 mu. Does that make sense? Yeah, all good? Okay, fine. Then we just need to solve each of these equations. Now clearly this is going to be harder to solve than the one we did before because we can't just cancel off like a mu or a lambda. So we actually have to solve it like a set of simultaneous equations. So let me just tidy this up ever so slightly. I'm going to get all of the lambdas and mu's on the same side and just a constant on the right hand side. Okay? So let's have a look at this one. So would you be happy? I could write lambda minus 4 mu must be equal to, well, -2 take away is -10. Happy with that? Okay, so that applies both ways. This one I could write 3 lambda plus 3 mu is equal to 2 minus 2 is 0. Okay? And then that implies both ways that we have, let's say, 2 lambda minus 4 mu has got to be equal to -12. Okay? That makes sense? Okay. So, here we go then. I am going to look at equation 1 and equation 3. Okay, so that would be equation 2. So what I'm going to do is I'm going to take equation 3 away from equation 1 away from equation 3. Okay, so I'm going to do 3, take away 1. So let me show you what I mean there. I'm going to write equation 3 out, so 2 lambda minus 4 mu equals -12. I'm going to write equation 1 out, which is lambda minus 4 mu equals -10. You notice how I'm setting that out and making sure the lambdas, the mu's and the constants all match up along with the equals. And if I'm taking them away from each other, I've got 2 lambda, take away lambda is just 1 lambda. -4 mu, take away -4 mu is nothing. And I have -12, take away -10, which is -2. Happy with that? Mm-hmm. So I have lambda equals -2. Okay. Now I've got to check, so using lambda equals -2, let's use it in one of the other equations. Let's use it in that equation. Okay? So let's see if it works to find mu. Okay? So if lambda equals -2, then it should be the case that I get -2, so using equation 1 this is now, let me switch back to black. I should end up with -2, that's my lambda, take away 4 lots of mu equals -10. Okay with that? Mm-hmm. So let's do this, so I get 4 mu equals -2 plus 10, which is 8, which means that mu should come out as 2. Okay, so let's give that a go. So basically I'm saying lambda equals -2, mu equals 2. I've got to make sure it works in all 3 equations. Okay? Are you happy that fairly obviously it's going to work in that first equation? Because that's literally where I got my mu from, by sticking that lambda into that first equation. So let's do it in the second equation to see if it works. Okay?
But could we just find it by reorder the equations and adding to them?
Yes, absolutely. That would work as well. Yeah, that would work as well. I'm just showing you one other way of doing it as well. Okay? So okay, we're going to check in equation 2 whether lambda equals -2 and mu equals 2 works. So it should be that I end up with 3 lots of -2 plus 3 lots of 2 should equal 0. So let's check what this equals. Negative 6 plus 6. Does that equal 0? Yeah, so that works. So far it's looking good. Let's try an equation 3 though, because just because it works in 2 equations doesn't mean it works in all 3. So let's check an equation 3. So I get 2 lots of negative 2 minus 4 lots of 2. That should equal negative 12. Let's give it a go. So I get negative 4 minus 8. That equals negative 12. So therefore, they must intersect. Yeah? Okay? So therefore, for equation 3, they must intersect. Okay, so these two things must intersect. If you want to find the point of intersection, you need to stick lambda equals negative 2 or mu equals 2 into one of these equations. Is that okay? Yeah, good. So just very quickly then, I get r is going to be equal to, let's put it in this one, 8 minus 2 lots of 1, which is going to be 6. 2 minus 2 lots of 6 is going to be negative 4. And negative 4 minus 2 lots of minus 2, that's going to be 0. So that's the point of intersection. Is that okay?